Good morning, friends. Today we will learn calculus, and subtopic is function of several variable. So far we have dealt with calculus of single variable, but in real world physical quantity often depends on two or more variable. So in this chapter we turn our attention to function of several variable and extend the basic idea of differential calculus to such function. In National Weather Service US and Meteorological Survey Canada, slide please, one table is that subjective temperature W that depends on actual temperature T and wind speed V, right? So here one table is there where actual temperature and wind speed is given. We can define the function f on actual temperature and wind speed, that is a function of two variable. From that two variables we can calculate the subjective temperature W, right? From this table we can see f of minus 5 comma 40 is equal to minus 14. Next. Now in other example, the volume of cone, we know that it is 1 by 3 pi r square h, where r is a radius of cone and h is a height of cone. So volume is depends on two variable, one radius and another is height. We can write V of RH is equal to 1 by 3 pi r square h. Next slide. So the definition of function of two variable is like this. A function of two variable is a rule that assign to each order pair of real number x, y in a set D is a unique real number denoted by f of xy. The set D is domain of f and the range of f is set f of xy such that xy belongs to D. Right. In this picture the domain D is given and one point xy is given, and the image of that one you can see on the z axis, that f of xy. If point is AB, then f of AB. The variable x and y are independent variables and the z is the dependent variables. Often we write z is equal to f of x comma y. Next slide. Now let us see first example. Consider the function f of xy is equal to table please. For function f of xy is equal to square root of x plus y plus 1 upon x minus 1. First question is that evaluate f of 3, 2. So f of 3 comma 2, this is equal to square root of 3 plus 2 plus 1 divided by 3 minus 1, right? This is equal to square root of 6 by 2. By this way we can find the value of f of 3, 2. Now the second question is find the domain of this function. Now this function is defined when the quantity under the square root sign is positive and the denominator is not equal to 0. So this term should be greater or equal to 0 and this is not equal to 0. So our domain is defined like this: the set of all order pair xy such that x plus y plus 1 is greater or equal to 0 and x minus 1 is not equal to 0. Now one can sketch this domain in plane. If you consider the x axis and y axis, this is y axis and this one is x axis. Now x minus 1 is not equal to 0. So we will sketch the curve x is equal to 1, right? So x is equal to 1 is this line. So we have to remove this point from the xy plane. We cannot take any value from this line, right? Now let us trace one more curve, that x plus y is equal to minus 1, right? So x of y is, if you take this one on this side, then f x plus y is equal to minus 1. So that line is this one. Now here the inequality is greater or equal to 0. So we will trace the full line from these 2 points. One point is minus 1 0 and another point is 0 minus 1. So here x plus y is equal to minus 1, x plus y is equal to minus 1. Now this line divides this plane in 3 parts. One part is x plus y is equal to minus 1, another part is x plus y greater than minus 1, another part is x plus y less than minus 1. Now see this point, origin 0 0. If I put 0 0 here, then 0 plus 1 is greater or equal to 0. Okay, it means that our domain is this part. So the domain of this function is this half plane, and it's remove this line also, right? Let us see one more example. Table please. Now example 2, table top. Here function f of xy is equal to log x plus y minus 1. Evaluate the f of 1 1 and f of e1. Table please. Okay. So first part, f of 1 1, right? F of 1 1, this is equal to log 1 plus 1 minus 1, and that is equal to log 1, and we know that log 1 is equal to 0. Now one more value we have to evaluate, f of e1, right? So this is equal to log e plus 1 minus 1, that is equal to log e, and we know that log e is equal to 1. The second question is find and sketch the domain of this function log x plus y is equal to 1. Now we know that log function is defined only on positive value. Okay, so this quantity must be greater than 0, otherwise this function do not make any sense. Okay, so our constraint is that x plus y is greater, x plus y minus 1 is strictly greater than 0. So the domain of f, this is equal to set of all order pair x y such that x plus y minus 1 is strictly greater than 0, right? Now if I want to sketch this domain, then I require the xy plane, y axis, x axis, and we have to trace this curve x plus y is equal to 1. If we trace x plus y is equal to 1, here inequality is strictly greater than 0, so we have to draw the dotted line. So this is the graph of x plus y is equal to 1. Now this line divides this plane in 2 parts, right? Now 1 is our domain, so if I put this origin 0 0, then minus 1 is not greater than 0, so this part is not in our domain, so this above part is in our domain. So this is the sketch of this graph. Now the third question is the find the range of this function. So the range of the function r of f is equal to log x plus y minus 1 such that x plus y minus 1 is greater than 0, right? Now let us see one more example. Find and sketch the domain of this function f of xy is equal to 1 plus x minus y square. So again here square root function, and square root function makes sense if the quantity under the sign is positive. So my domain is set of all order pair xy such that 1 plus x minus y square is greater than or equal to 0, right? So let us trace this curve, that 1 plus x minus y square is equal to 0. So from this one we get x y square is equal to 1 plus x, and this is the well known curve, it is a parabola, right? So let us trace this curve. and here inequality is greater or equal to, so the points on the curves are in the domain. So if I trace this curve is symmetric about the x-axis, right, and the vertices is 0 1. So this is this parabola, right. Now this parabola y square is equal to 1 plus x. Divide this plane again in three parts, one equality part, one greater or equal to, one less than, right. Now see the origin. If I put 0 0 here, then 1 is greater than 0. It means that our origin is in our domain. Okay, so the domain of this function is this part, right. Now slide please. Okay. Now here there are other two functions. F of xy is equal to square root of x plus y, again square root function, so x plus y should be greater than equal to 0. So the green shaded part is the domain of this function. In the next question, f of xy is equal to square root of y minus x square, again y minus x square should be greater or equal to 0. So we have to trace the parabola, and in denominator 1 plus x square is there, right. So in this case the denominator will never 0, right, if x square is equal to minus 1, right. If x square is equal to minus 1, then x is a complex number. So the shaded region is the domain of the function f of xy. Next slide please. Now function of 3 or more variable. The temperature on the earth surface depends on the longitude x and latitude y of the points and on the time t. So now we have three variables, one is x, another is y, and other is time t. So the temperature is a function of x, y, and t. So this temperature function is three variable function. Similarly, function of n variable can be written as f of x1, x2, comma, and so on xn. So this is a function of n variable, right. Next. So let us see one example for finding the domain for function of three variable. Now in function of three variable, our domain is in the space, right, it is not in the plane. See, a function is f of x, y, z is equal to log x z minus y plus xy sin z. Now in this function makes sense if this quantity is strictly greater than 0, right. It means that we have to trace the surface z minus y is equal to 0, right. So this implies z is equal to y. Now this is a one equation in 3 dimension. So one equation in 3 dimension represent a surface, right. So let us trace this surface in a space. So for space we have to take the 3 axis, the 3 dimension figure, right. Consider this as a z axis, this as a y axis, and this as a x axis. So z is equal to y is a plane, right, and that plane is passing from the origin. If you trace this plane, right, it's look like this. It is an infinite plane, right. This plane is z is equal to y, right. Now here we want z minus y is greater than 0, right. So if I take z minus y is greater than 0, then the upper part of this plane is my domain, right. Upper part of this plane is my domain. So whenever there is a function of 3 variable, our domain is a subset of R3. Next. Okay. Now next topic is a graph of function. Still we draw the domain of the function. Now graph of function is defined like this. If f is a function of 2 variable with domain D, then the graph f is the set of the all points x, y, z in R3 such that z is equal to f of x, y, and x, y is in the domain D, right. Let us see one example. Sketch the graph of the function f of x, y is equal to 6 minus 3x minus 2y. Table please. Now here f of xy is equal to 6 minus 3x minus 2y. So we can write like this, that z is equal to 6 minus 3x minus 2y. From this one we can convert this equation in the standard form, that 3x plus 2y plus z is equal to 6, right. This equation is look like these things, lx plus my plus nz is equal to d. Now this is the standard equation of the plane, right. Again we rewrite this equation in the easier form. Divide this by 6, so x divided by 2 plus y divided by 3 plus z divided by 6 is equal to 1. So this equation of plane is of the form of intercept, where x intercept is 2, y intercept is 3 and z intercept is 6, right. So if we have the 3 points of the plane, then we can trace that plane with help of these 3 points. Okay. So here z intercepts is 6, so this point 0 0 6 is in our plane. X intercept is 2, so this point, consider this x axis, this is z axis and this is y axis. So 2 0 0 is on the plane, and y intercept is 3, so take this point as a 0 3 0. Now these 3 points determines one unique plane. So our plane is passing from these 3 points, so I can trace this triangle. Okay, so the plane passing from this triangle up to the infinites, right. This is our required graph of the function f of xy is equal to 6 minus 3x minus 2y. Let us trace one more curve, standard curve. Sketch the graph of the function f of xy is equal to square root of 9 minus x square minus y square. So we rewrite this equation in the standard form.